Hello, welcome back. We're about halfway done. We should be able to finish the chapter with this. So we ended with this question: why is the light radiated by the sun yellow, but light radiated by the earth infrared? Now remember, yellow's kind of in the middle, and that's just the sun does not emit yellow light. First of all, the sun emits every color of light. It emits every form of energy. It just so happens to emit more yellow energy than other energies, which is why it appears yellow. It's just because it's more yellow than other things. But all of the light colors are there. Otherwise, if you hold a prism, you wouldn't get all the colors. But you do get all the colors because all the colors are there. It's just like if I took white paint and added a little bit of yellow to it, the white would still be there, but it would look a little yellowish. But the Earth emits mostly infrared, which is lower energy. Why is that? Well, the sun is hotter. Higher temperature means more energy. Higher temperature, higher energy, higher frequency. And yellow light is a higher frequency, higher energy light than infrared. Okay. So what substances emit radiant energy? Everything. Everything emits energy. Everything has some level of energy that it's given off. Unless you just happen to be the coldest point in the universe. So if everything's giving off, what about absorbing? Well, everything can absorb energy, but there are things like we have black bodies which appear to not give off any energy and they appear to absorb energy. But in general, what I want you to know for this class, good emitters are good absorbers. So it's the opposite of conduction insulation. If you're a good conductor, you are a poor insulator. If you are a good emitter of radiation, you are a good absorber of radiation. Good emitters are good absorbers when it comes to radiant energy. So like hot metal gives heat off really well. It can also absorb that heat really fast. Good emitters, good radiators. So if everything is emitting energy, which I already told you, why doesn't everything finally run out of it? Well, because you're emitting energy, but you're also absorbing energy, right? Even if you're getting colder, colder just means you're emitting more radiant heat energy than you're absorbing. If you're getting warmer, it just means that you're absorbing more than you're radiating. It doesn't mean that you've stopped radiating. It just means that you're absorbing more. And absorption emission. What do we need to know here? Not a lot. Where are we getting? All right. A blacktop pavement and a dark automobile body may remain hotter than their surroundings. That's because they're absorbing. Excuse me just a second, I need to cough. So they're absorbing that heat all day into that black object. So they're absorbing all that energy. They're a good absorber. If you are a good absorber, you are a good emitter. So black actually gets colder faster at night too. So it kind of works both ways. You absorb a lot and you give off a lot in terms of speed. So good absorbers are good emitters. A perfect absorber would absorb everything and appear perfectly black. You would radiate nothing. Now there are different levels of that too. One thing I like to point out here is there was a wall at the last Olympics. It's like the darkest wall there is because there is no such thing as perfectly black. At least we haven't invented a substance or found a substance that absorbs all light energy. But they found this one surface that was like so dark, and apparently it's really spooky to look at it when it's clean. The dust on it actually reflects light, but the surface itself doesn't. So it kind of creates this creepy thing. But if you're a really good absorber, remember I said you're a really good emitter, but that doesn't mean that you will emit the same energy. Like, for instance, light passes through your window and it is absorbed by your carpet as light. Your carpet gives that heat, that energy back off as heat or infrared. So light and glass allows light to travel through it very easily, but glass is actually a poor conductor of infrared. So That's why greenhouses work. The light comes in and it gets converted to infrared, and that infrared stays in. So it holds the heat in, but it allows the light in, but it doesn't allow the heat out. So you can change the type of energy. You can absorb one kind of energy and emit a different kind of energy, at least in terms of wavelength and frequency. I have a little box like this. I'll save that and think I can do it through in class. But this is a white box, and if she closes it, through the hole it appears to be black. And a lot of people will say, well, it's because there's no light inside of the box when you close it. But that's wrong, because the box is open. Light does go into the box. And white is reflecting that light all through the box. The problem is, even though that paint is white, it still absorbs a little bit of the light and transmits it into other energy, like heat or something. And so the light is still going in to the box. It's not that there's no light in the box, but the light doesn't just come right out of the box. The light has to bounce around in the box before it makes its way out through that hole. And because of that, by the time it's bounced around in the box, it loses all of its energy, or it's been converted into another wavelength that is no longer visible. So it's not that when you close it, no light is going in. It's that when you close it, no light is able to come back out. Because light is still going in through the hole, just not as much light, because when it's open, obviously there's a whole bunch of light going in. And here's kind of a drawing to show that. There's a lot more reflections that all that bouncing around converts or absorbs a lot of that light. And then you just don't see it again. Anything with a mirror-like surface reflects most of the radiant energy it encounters. So like silver is a very poor absorber, poor emitter of radiant energy. So that's just a little thing to know. If you reflect energy, that means that you are not absorbing it, I guess, is the take-home message there. What else do we need to know here? Let's do this one. If a good absorber of radiant energy were a poor emitter. Now remember, I told you that's not true. If you're a good absorber, you are a good emitter. But if a good absorber were a poor emitter, how would its temperature compare? If you were absorbing but not emitting, you would very rapidly heat up until eventually you would combust or explode. You would just keep heating up, and you don't want that to happen. So how does an object's emission rate compare with its absorption rate? They tend to be about the same. Now I know I said this was going to be the last video, but I'm actually going to stop here and take a break, and because my throat's about to go, and then I'll do the last little bit. This was only like an 8-minute video, so the next video will probably be like 5, but I need a short break.